indexing, and that is known as the bitmap index. Right, so very interesting and very simple indexing technique that we are going to discuss now. So in bitmap index, or when we should go for this bitmap index, if we want to query on multiple keys, if we want to have a query on multiple keys. We have gone through this concept earlier, what we mean by multiple keys. Say for example, we are having a statement like select, say star, from say student, where, let us assume that we are having one attribute, say gender equal to say F, and, right, one more condition we need to mention. Let us assume that gender equal to F and grade is say A, something like that. So here we are using multiple keys. This is one key, gender, and this is other key, grade. These two keys are being used, multiple keys are being used to extract the relevant data from the table, right? So bitmap indices are special type of index that is designed especially for efficient querying on multiple keys, right? So here, while creating the bitmap, we assume that the records in a relation are numbered sequentially, say from 0. So if I'm having say student record, a student relation, and if I'm having several records in my student relation, then these records are numbered. So this is 0th record, first, second, third, and so on. Right? So records in a relation are assumed to be numbered sequentially from 0. Right? Now, what next is when to use such kind of bitmap index. The bitmap index are applicable on attributes that take relatively small number of distinct values. I repeat, bitmap indices are applicable on attributes that take relatively small number of distinct values. What we mean by that? Say for example, if we are having the attribute say gender, then possibly we are having now only two values, M and F, say for example. So this attribute takes only two distinct values. Suppose I am having the attribute country. So I am having some limited set of countries, finite limited set of countries or state or something like that. Or we may see one more example. We may have the income level as one of the attributes. So we may split the income of the instructor in certain levels. Say for example, up to 10,000 we are having say level 1, 10,000 to 20,000 we are having level 2, 20,000 to 50,000 level 3, and so on. So ultimately the only few levels we are having. So if my attributes are taking relatively small number of distinct values, then we should prefer to use such kinds of bitmap indices. So what is a bitmap actually? A bitmap is simply an array of bits. Bitmap is array of bits, and with respect to a particular relation and with respect to a particular attribute under consideration, we may create the bitmaps, right? So let us see an example how to create the bitmaps and how to use those. See here, we are having one relation with 4 attributes. So what are the attributes in this relation? Name, gender, address and income level. What are those? Name, gender, address and income level. And we are having several records. Those are being stored in the relation. Okay, now if I look at this particular relation, then I may find that this attribute, say gender, is having only 2 distinct values, M and F. Also, if I look at this particular attribute, say income level, I am having very few levels of income, right? So if the attribute takes relatively small number of distinct values, then these bitmaps are beneficial. So we may think of creating the bitmaps for these attributes. So how we are going to create the bitmaps? So as I stated, bitmap is array of bits, right? So how many bits will be there in my bitmap? So bitmap will contain the number of bits equal to the number of records. I'll repeat. The size of the bitmap depends upon the number of records those we have in our table. So if I am having 100 records in my table, my bitmap size will be 100 bits. If I am having 5 records, then my bitmap size would be 5 bits. So in a bitmap, for value V, the bit for a record is 1 if the record has that value V for the attribute, otherwise 0. What it indicates? See, suppose we want to create the bitmap for this attribute gender. So this attribute gender is having 2 distinct values M and F. So for each distinct value of the attribute, we should create one bitmap. I repeat, for each distinct value of attribute, we should create one bitmap. So for gender, we are having 2 distinct values M and F. So we are having 2 bitmaps. Bitmap for value M and bitmap for value F. Right? Now, how we are going to create this bitmap? See here, we are having 5 records and those are being numbered as 0, 1, 2, 3, 4. Correct? Now, as I stated, the length of the bitmap is same as the number of records that we are having. So, in our case, for this particular instance of this relation, I am having 5 records. So, length of my bitmap would be 5. Right? Now, see here how to create this bitmap for M. So, the 0th record, what is the value of gender here? It is M. We are creating the bitmap for M. And the value for this 0th record is M. So, this bit is set to 1. For first record, the value is F. So, M is false. Right? So, for M bitmap, I am having this first record bit as 0. The second record, this is my second record. So here, once again, I am having gender value F, which is not M. So not M means 0 for M bitmap. For this third record, I am having gender value as M. So it is true for M. So I am having here 1. For this fourth record, the gender value is F. So once again, it will become 0. The bit corresponding bit will become 0. So if I look at this M bitmap, then how I can interpret this M bitmap? If there are 5 bits, meaning there are 5 records, we begin from numbering as 0, 1, 2. So for 0th record, the value of gender is 1. The value of gender is M because this bit is set to 1. For third record, the value of gender should be M because once again this is set to 1. Right? Similarly, we can create the bitmap for F, female. So here for the first, second and fourth record, the value of gender is female, and that is why in bitmap of female, I'll be having the respective bits set to 1 and the rest of the bits are zeros. So this is how we need to create the bitmap. Now, see here the bitmap for the other attribute, that is income level. So, right now this is the instance having only 5 tuples in the relation, right? But actually we are having say 5 income levels. So, for those 5 income levels, we should have a separate bitmap. So, 5 distinct income levels. So, we should have 5 different bitmaps. The length of the bitmap once again is equivalent to number of records in my table. So see here the bitmap for L1. So for L1, for 0th record is having income level L1. So for 0th record, that bit is set to 1 in my L1 bitmap. Right? Now, if I go for first record, the income level is L2. Right? So if you look at this bitmap for L2, this bit, first bit is set to 1 because for this record I am having this value L2. Similarly, if I go for this second record in the table numbered as 2, then the income level is L1. So once again in my L1 bitmap, this respective bit for second record is set to 1. For this third record, income level is L4. So in the bitmap of L4, this third bit is set to 1. The record numbered 4 is having the income level L3. So in this L3 bitmap, I am having this fourth bit which is set to 1. So I hope you must have understood how to create the bitmap. Yes or no?
Yes, ma'am.
Right. Now, once we have created such kinds of bitmaps, how these bitmaps will help us to extract the data. Right? Now, let us see how these bitmaps can be used. So, bitmap indices, as I stated earlier also, are meaningful for the queries on multiple attributes. Meaning, whenever we are having the queries with more than one attributes and these conditions or predicates are concatenated with the help of some logical operators like this and that or this or that, something like that. Then we may use these bitmap indices so that we can expedite the output of our queries. Such kinds of bitmap indices are not typically being used for single attribute queries. But if we are having multiple attribute queries, right? And that too, the attributes, those are used for querying, are having comparatively small number of distinct values. Then we should think of this bitmap index. So as I stated, queries wherein we are having some AND operation, we are having some OR operation, or we are having some NOT operation. In such situations, we may go for bitmap indices. So let us see the example. Whenever we are using such kinds of logical operators, right? The logical operators require the operands, those are in the form of bits, right? So every operation AND and OR will take two bitmaps of same sizes, and the corresponding operation is performed, right, with respect to two bitmaps. So if I am performing AND operation on these two bitmaps, see here, the size of the bitmap is same. So every bitmap is using here 6 bits, right? And we are using AND operation. So this is bitwise ANDing. Bitwise ANDing. What does this mean? This high order bit gets ANDed with this high order bit. So 1, 1 is 1. 0, 1 is 0. 0, 0 is 0. 1, 0 is 0. 1 and 1, sorry, 1 and 1 is 1, and 0 and 1 is 0. So it is bitwise ANDing. Similarly, OR operation can also be performed bitwise, right? So two bitmaps are being presented and we are ORing, bitwise ORing those bitmaps. So any of the respective value is 1, then the OR operation will produce that, or will set that output bit as 1. Similarly, the complement operation or NOT operation, which takes a single operand and not a particular bitmap, will revert that particular bitmap, right? So this is how actually the bitmap operations are performed. So with respect to our table or the relation that we have discussed, wherein we had 4 attributes. And what were those 4 attributes? Name, gender, address and income level. And we have created the bitmaps for gender and income level. Now, if we are having a query like find the males with income level L1, find the males with income level L1. Let us go back. This is our example. These are the bitmaps. So what we want to do? We want to find males with income level L1. So what we need to do? What is the bitmap? We are using 2 attributes, male and income level. So where is the bitmap for male? This 10010. So we'll be using 10010. This is the bitmap for male, right? With income level L1. So we need to consider the bitmap for L1, and that bitmap is 10100. What we want? We want to find males with income level L1. So simultaneously both the conditions should be satisfied, right? So obviously the operation that we need to use is AND operation. Okay, so if we perform AND operation with these 2 bitmaps, what we will be getting? 1, 0, 0, 0, 0. Is that correct? Yes?
Yes, ma'am.
Right. So this is the result that I am getting out of these two bitmaps after ANDing these two. So how to interpret this result now? In this result also we are having 5 bits and the 0th bit is set to 1, meaning both the conditions are satisfied for this 0th record. So we need to output this record, 0th record. See here, for this record, gender is M and income level is L1. And how we have found out that this is the appropriate result, 0th record, by ANDing these two bitmaps. So after ANDing, whichever bits are set to 1, those tuples from the table we need to extract as output. So here 0th bit is set. So 0th tuple from my relation needs to be extracted as the output of the query. Any doubts so far? Yes?
No doubts,
Any
ma'am.
doubt? So please now work on another query. Find females with income levels L1 and L2. Sorry, L1 or L2. L1 or L2. Find females with income levels L1 or L2. So give me the answer now and tell me the process that you are using. Yes. Yes, what you will do? Please pick up. How to get the solution for this problem? What has been asked for? Find. Yes.
Here we have to find females with income levels L1 or L2. First, we
Yes.
find the bitmap for gender female, that is 01101, and we have to find the income levels L1 or L2. There is a OR operation between L1 and L2, and the result of L1 and L2 is ANDed with the bitmaps of females. Then we get the females with income levels L1 or L2.
So this is the bitmap for gender F. This is the bitmap for L1 and this is the bitmap for L2. So we need to consider these three bitmaps. So first of all, what we need to do is we may OR this L1 and L2, L1 or L2 has been mentioned. So this bitmap will produce the result. This OR operation will give me 1, 1, 100. Correct, na? L1 or L2. 11100. So what I'll do, I want now females with L1 or L2. So L1 or L2 has been computed here using this OR operation. Now I need to make use of this F and this intermediate bitmap 11100, right? And I need to perform AND operation for this. So what will be the result of ANDing these two? 01100, right? So which two bits are set to 1? This is 0th record, first record and second record. So if we look at here the first record and the second record, here we are having gender equal to F and the income level equal to L1 or L2. Here it is L2, here it is L1. Right? So this is how we need to solve such kinds of queries, or this is how actually our system solves the queries if the bitmap index are being employed. I hope you must have understood this concept. Right. So we have gone through such kind of queries. Those can be solved by making use of this bitmap index. So this bitmap index can retrieve the required tuples in the output, and one more operation that we may perform efficiently is counting the number of matching tuples. Counting the number of matching tuples. What it means counting? Say for example, males are there at an income level. What I want, say for example, I want to count males under income level, say L3. Let us assume count males under income level L3. Then what I can do? I can simply refer to the bitmap of male, right? I can refer to the bitmap of L3. Whenever I AND these two bitmaps, then what I'll get? I'll get the male who has the income level L3. And if I count the number of bits in that output, then it is possible for me to get that count. Or in this example also, we have extracted the tuples now. So find females with income levels L1 or L2. Ultimately, we are extracting in our output the tuple number 1 and tuple number 2. So this would be the output. But if I am asked to count how many females are there with income level L1 or L2, then simply what I will do is I am having this resultant bitmap. So I'll be counting the ones in this bitmap. So obviously I am having two ones. So sum is 2. So simply I'll say that the number of females with income level L1 or L2 are 2. Right? So simple it is. So both such kinds of operations can be efficiently performed. We can retrieve the required tuples based on the attribute values, and also we can count the number of matching tuples using such kinds of bitmap indices. Right? Now, bitmap indices are generally very small compared with relation size. What we mean by that? Say for example, if our record is of size 100 bytes, if our record is of say size 100 bytes, then space for a single bitmap is 1 divided by 800 of space used by the relation. See, I am having the length of the bitmap is equal to number of records. Those I am having in my relation. Now, if I am having lots of records, having some size, say 100 bytes, irrespective of the size of the record, the space required to store one bitmap, irrespective of size of the record, I will require only those many bits, 1 bit per record. That is only the requirement. So if the record is 100 bytes, then the space for a single bitmap is 1 divided by 800 of space used by the relation, if the number of distinct values are 8. So bitmap requires only 1% of the relation size. 1% of the relation size. So I am having the record of 100 bytes and I am having one attribute with 8 distinct values. Then obviously I need to prepare 8 bitmaps, 1 bitmap per value. Record size is 800 bytes. So obviously a single bitmap in this situation will take 1 divided by 800th part of space. So it is almost 1% of relation size. So bitmap indices are requiring very small memory. But we should be very careful while performing the deletion operations with respect to bitmap. So how actually the deletion operations are being performed? To perform deletion operations, one more spatial kind of bitmap is being generated, and that bitmap is known as the existence bitmap. What does this mean? Suppose I am having say 0, 1, 2, 3, 4, 5, 6, 7 and so on, those many records. So initially, whenever we are preparing the bitmap, we are preparing the bitmap such that in that bitmap, this every record is being considered. So if I am having say 100 records or 101 records, then this bitmap is having 101 bits. So 1 bit per record has already been considered. Now, if I am deleting particular records, say for example, if I am deleting this 4th record, if I am deleting this 7th record, and so on, then if I think of once again regenerating the bitmap, then this process is not advisable. Instead, what we can do is we can generate one more bitmap known as existence bitmap. So in this existence bitmap, once again, if I am having 101 records, in existence bitmap also, I'll be having 101 bits. So if 0th record is existing, then that bit is set to 1. If first record is existing, then it is set to 1. Second record set to 1. Third record set to 1. But 4th record is being deleted. So the respective bit in my existence bitmap would be set to 0 because that has been deleted. 5th, once again 1. 6th, 1. But 7th record gets deleted. So the respective bit in my existence bitmap will be replaced by 0 and so on. So by referring to this existence bitmap, we can understand which are the actual tuples. Those are present in my relation. Instead, so by making use of this existence bitmap, we are reducing the overhead for regenerating the bitmaps in case of deleting some records. Right? So bit I is 0 if record I does not exist, and bit I is 1 if the record exists. So that is what we mean by existence bitmap. And by making use of this existence bitmap, this deletion of records can be efficiently done. Right? So I hope you must have understood these concepts. I am giving you one exercise for bitmap indices. So please take down this problem and you are supposed to solve this. This is the table given wherein we are having 8 records. The attributes are part number, part color and price. What has been asked for? Construct bitmap indices on the attributes, part color and price, dividing price values into two ranges, below 250 and 250 and above. Secondly, consider a query that requests all parts of red color with a price of 250 or more. So you need to provide the answer to this query using the bitmap index. Outline the steps in answering the query and show the final and intermediate bitmaps constructed to answer the query. So this is what the problem statement is. So what you need to do is, you need to create the bitmap indices on two attributes, part color. So I am having distinct values as red, white, black, 3 distinct values. So 3 bitmaps. Every bitmap is having length 8 because there are 8 records. So you need to create a bitmap for red, bitmap for white, bitmap for black. What next? It has been asked to distribute these prices in two ranges. So you need to create a bitmap for below 250 and 250 and above. So these two bitmaps once again. And based on now these bitmaps, you need to solve this query. And you need to write the intermediate steps also, producing the result. Got it? Yes? Any doubt so far? Any doubt so far?
No, ma'am.
Fine. So with this, actually we are concluding our discussion with indexing. So simply I would like to give you one concept, or let us see how actually this indexing is being implemented in SQL. So in SQL, we are having the statement create index, right? So we are having the tables or relations with us. So if we would like to create the index for a particular table or a relation, then how we are going to make use of this create index statement? See here, create index, then name of the index that we would like to give. On which relation we would like to build the index. So on relation name. Okay, and further we need to provide in parenthesis the list of attributes which are the search keys for creating the index. Say for example, if we would like to create the index for instructor relation on the search key value department name. Then we are going to write the statement like create index, department index is name of the index that we are giving on table instructor search key value department name. So create index department index on instructor parenthesis department name. This is how this statement looks like in SQL. If we want to remove or drop the index that has already been created, then what we can do is we can simply write drop index and name of the index. Right? We are having one more variation of create index, create unique index. So when to use create unique index? Create unique index is being used to indirectly specify and enforce the condition that the search key on which we are creating the index is a candidate key, because candidate keys are the unique keys. So create unique index will specify that the search key that we are using to create index is the candidate key.